Okay, so in this lesson, we are going to look at sections 9 and 10 of chapter 14. And in section 9, we're going to look at the effect that structure has on acids and base properties. So the first thing we're going to look at is a binary acid. So to be a binary acid, you have hydrogen connected to an anion, so one nonmetal atom. So in this case, all the nonmetal atoms are halogens. And if we look at this, we can talk about what happens as bond strength increases. And we can see as bond strength increases, you have a weaker acid. Now let's talk a little bit about HF, because I think it behaves probably differently than we would anticipate. So if we think about what we know in terms of electronegativity, fluorine is the most electronegative element on the periodic table. So we would expect the polarity between hydrogen and fluorine to be high. And for that reason, we would predict that it would probably be pretty easy for fluorine to break the bond between hydrogen and for hydrogen to dissociate. But we see that that's not what happens. And we base this on its unusually high bond strength. And that's what accounts for this being a weak acid instead of a strong acid. All right, let's talk about the structure of oxyacids. So to be an oxyacid, you have ionizable hydrogen attached to an oxygen, and that oxygen is part of a polyatomic ion. And so in this case, we're going to look at oxyacids for a series. So here's my series. I have hydrogen, 1 chlorine, and 1 oxygen. I have hydrogen, 1 chlorine, and 2 oxygens. Hydrogen, 1 chlorine, and 3 oxygens. Hydrogen, 1 chlorine, and 4 oxygens. So this would be a series. And what we notice for the series is that the acid strength increases with an increase in oxygens. Okay. So HClO4, the one that has 4 oxygens, is the strong acid in this series of oxyacids. Okay. So what accounts for this? What is the contributor here? So what's happening is that the oxygen atoms are drawing electrons away from chlorine. As that oxygen atom draws the electrons away from chlorine, this polarizes the OH bond. Okay. So much so that that OH bond weakens. And as that OH bond weakens, the hydrogen can dissociate. All right, and then the last topic is that we're going to look at the electronegativity value of X. And so if we look at my chart, we can see that X in some cases is an element. In other cases, it's a functional group. And it's for a series of oxy acids and the Ka values. So when I'm looking at this chart, we can see if I'm going this way in the chart, electronegativity increases. And if we go the same direction in the chart and we talk about Ka, we can see that Ka also increases. And we know anytime Ka increases, it means we're producing more product. So we're able to weaken that bond that hydrogen has, and that hydrogen can easily dissociate off. All right, and then the last section is about acid-base properties of oxides. And there are two oxides. There are acidic and basic oxides. So let's look at the acidic oxide first. To be an acidic oxide, you have to be a non-metal oxide. So the non-metal oxide we're going to use in our example is SO3. And so I'm going to draw its Lewis structure here. And what happens to oxides is that they react with water. And in the case of a non-metal oxide, when it reacts with water, we produce an acid. Now again, in order for something to be an acid, we have to be able to break off hydrogens. Okay, so let's talk about how we're able to break off this hydrogen. Sulfur has a high electronegativity. And then the elements that have a high electronegativity, they're going to draw electrons toward it. So this actually draws electrons away from the OH bond. So that, again, that OH bond is going to weaken and the hydrogen ion dissociates. All right, let's look at a basic oxide. So to be a basic oxide, you have to be a metallic oxide. So we're going to use calcium oxide. So calcium's in group 2. And so that would make it a metal. Again, they have to react with water. And in this case, we make calcium hydroxide. Now, if this is a base, then what's going to break off are hydroxide ions, not hydrogen ions. So let's talk about what happens here. The central atom here is calcium, and this has a low electronegativity. So this means that it's going to keep that bond between oxygen and hydrogen bond strong. And so what's going to dissociate here is that OH bond.